All right, we're well on our way here into the paneling. We've got the rear section in, 1,000,000 holes drilled, all deburred, and spent a lot of time lining them up. So this video is going to talk about that stuff, and also we're going to cover the insulation that I'm going to be using in the car. This isn't the funnest job, so I'm happy that it occurred at the start of the job whilst you've got maximum enthusiasm. But if you have any questions, let me know. It was a very time-consuming process even getting this far, and we're nowhere near done yet. But it's very satisfying when you're at the end and you can manage to see all of the holes that are neatly lined up and you've clearanced everything correctly. So here we go. We're at the stage of paneling where we need to consider insulation for acoustics and for heat control. This is something that has been problematic for Ultimas when not done well, so it's something that needs to be pretty well considered. And I'm going to give a bit of an explanation in a somewhat simplified manner about what we're trying to do here. Now, acoustics, you're actually trying to change the natural frequency of particular panels by adding some weight or subtracting it so that you can change the natural frequency of that panel so it doesn't vibrate or transfer energy. That's where you have stuff like this sound deadener that is basically just that thick black stuff that you would have all run into when you were pulling panels apart on cars previously. In regard to heat, we need to deal with conduction, which is a transfer through direct contact, convection, which is the transfer of energy through buoyancy-driven gas or fluid flow, and radiation, which is the transfer through electromagnetic means. Now, when we choose our insulation, there's a couple of things that we really need to think about. Firstly, you need to think about the ability of the material to withstand the environment in which it's installed, especially if it's in direct contact for extended periods and it looks like it's bonded with adhesives, for example, that you also need to be aware of. In an engine bay, that's 200 odd degrees plus, and you need to make sure that it's not it's fire rated so that it's not going to propagate fire or spread any issues if there is one, God forbid. It's part of the reason why we'll see glass wool insulation here rather than polystyrene foam that you have in your esky for keeping your beers cold, or coolers if you're in the USA. And then we need to think about against what heat transfer we're trying to insulate. So, are we trying to deal with conduction, convection, or radiation, or a combination of both? There's no point having shiny silver material on something that really doesn't get any exposure to radiation. Conduction, the easiest way to deal with is just creating an air gap. That's sort of the main way that we can deal with it without getting too technical. And then convection, obviously gases are pretty good thermal insulators in comparison to liquids and solids. So we can further improve that performance by creating a bit of resistance to natural convection. So what I mean by that, and I'll go a little bit Jason Finsk here because it makes it a lot easier to explain, is if we've got a hot side and a cold side, and we've got a medium in the middle, we're going to have natural convection occurring here in the center. What we can do is we can add some baffling to that through either a closed cell foam or, you know, some glass, like blown glass wool or asbestos, which is actually a really good material, but absolutely shithouse for you. And that will prevent, or not prevent, but greatly reduce the amount of convection here because of the amount of drag that you have because of the surface area of all the material in here. One thing that I also want to comment on here is that the energy transferred through this panel is going to be largely determined by the temperature difference here between the hot and cold side. So when you are choosing insulation, you get quite a bit of resistance here from your source to the next side of this panel. But then if you have another insulating medium, you don't have the same delta T across here. So you'll get a diminishing return on that second insulation panel. So what happens in that sense is that there's no point putting in 50 layers of insulation. The first few will do a lot, and then the remaining ones will do a little. And unless you're into fatties, it really doesn't help a lot. So I would recommend not going down that path of going, you know, absolutely insane and thinking that you're doing the same thing through this third layer of insulation that you're doing through the first two. Now, radiation of wavelengths like this are best dealt with high emissivity surfaces like aluminium foil. Real gold is slightly better and it doesn't tarnish, but the stuff that NASA uses is actually a bit of a hybrid thing called Captain or something like that, which deals with a wide range of spectrums. There's a guy named Stefan Boltzmann, or the Bolt if you want to refer to him that way, that had a lot to say about that, and you can read up on him if you want to get off on that. Without getting too technical, you just need to stick aluminium or a shiny metallic surface to the thing that you're trying to protect. That'll look after the radiated heat component as well as you possibly can. But the fiberglass backing and technical data of the specific material is what you really need to look at. And beyond that, gold was obviously popularized by the McLaren F1 and, you know, pimp jewelry. So you probably want to cover a few parts just because it'll look absolutely awesome. I've seen a couple of guys do their rear clams with just some gold highlighting, and it looks pretty good. But in terms of actual performance, the silver stuff's as good or better generally with what's available on the market. When that roller tape there was like $100, which is probably a bit stupid. Beyond that, select based on cost and how reliable the retailers are. I got a lot of the stuff from car builders because they provided really good technical data on their stuff. Given the temperature tolerances, thermal conductivity, moisture absorption, weight, and they also had installation kits and videos on their website, which was really good. And their service was actually pretty impeccable. They got all the stuff to me really quickly. If you look here on this one here, as an example, which is this thicker silver stuff that I'll be putting on the face of my firewall, it gives a simplistic test example. You know, 176 degrees on one side and you've got 65 degrees on the other. It deals with the radiant portion through the silver, and then it's got some, what I would say is almost certainly fiberglass insulation on the back, which is reasonably thick in comparison to, say, this silver stuff, which is quite hard wearing but pretty thin. And the gold stuff looks great, but is actually pretty much paper thin. The gold stuff and the silver stuff there was from Mishimoto, and so, you know, I just got that, which was because it is thin, you know, you can install it in certain places that this one doesn't go, but it won't perform quite as well. So the car builder stuff does Acoustic Liner, which is this dual density closed layer foam. If I can get this to focus on that. Now, the main thing with that is that closed liner, I'm going to be using it as an acoustic and a thermal insulator because it does have pretty good thermal properties. And that closed cell foam also means that if you spill any liquids on it, it doesn't actually seep through. So if you're putting it underneath your carpet, for example, and you have someone in the car, or someone shits themselves because they're in a Group C race car with number plates and don't realise how fast they can be, you're going to have some hope of at least cleaning it up by ripping out the carpets and not having to deal with an absolute nightmare. The car builder's info on their sound deadener was actually more comprehensive than the Dynamat stuff. They had great sales spiels, like, you know, the sound deadener is going to stop all of the world's hunger and everything else, but it didn't actually give any data, whereas these guys were really good in that sense. Yeah, anyway, acoustics are a bit of a larger subject, but you're basically going to add some weight to the panels to shut them up. Now, what I'll give you as an idea is just sort of a worked example is if we have the engine bay panel here, that's actually a double skin panel with a void in between the panel that's installed there now and the panel that's going to go on the engine bay side. We're going to expose this side to sort of 200 odd degrees or so, which is why we're going to use this this thicker foil here for the radiant component, and also it's got a decent, you know, bit of thermal insulation there for the conductance. If you look up here at its tech data, 250 degrees is what it can withstand. It's got a good amount of thermal resistance. They give it in conductivity, which is the inverse way of looking at it. So you need to be able to compare those two. If we use this example here, we're going to have sort of 200 degrees. We're going to be down to maybe 80 or 70 degrees on the other side. Then what we might do is we might stick another layer of this on the inside of that panel, which is going to offer no help in terms of the radiation component, even though it does have the foil backing to it. But the reason we'll do that is just to try and be a bit kinder to this acoustic liner that we're going to put in the center beyond that, which, if we can look over here, we need to make sure it's going to be able to deal with the temperatures. 120 degrees sustained, perfect, that's what we want. Then we might put some of the sound deadener on the inside panel and leave it at that. That should give us a pretty good level of insulation. If I have room for it, I might stick a couple of layers of this acoustic liner just as a bit more of a thermal insulator within the void. Just installing the supports, the angle brackets for the rear bulkhead second skin. Just be aware with this one when you're doing it. First of all, you need to make sure that you don't fix this panel in place as the instructions suggest, because it'll make it very difficult to get access for both your drill and also when you're putting insulation on the back bulkhead panel, a number of other things. So don't do that before time. The other thing is that when you're doing any of this paneling, another guy who has an Ultima named Doug, he mentioned that lots of the factory suggested cutouts and stuff like that can actually be improved on if you just fit the panel and just refine them to the specifics of your chassis. I mean, obviously these chassis are made on a jig and that sort of stuff, but they are hand produced. So, you know, you've got people who are going to have minor differences just in terms of tolerance because of the way that these are manufactured. They're not done on a robot like you'd see in a modern manufacturing situation. Quick tip on rivet spacing. Obviously, when you have these indentations to suit your roll bars so that you can bend the edge around, you need to be aware that they're not necessarily going to match with the 30mm spacing of your rivet lines. So if you actually space them at 30mm intervals in between each of those sections, you'll have a very neat spacing and you won't end up with one rivet directly adjacent this sort of bend line or cutout for your roll bar. I've noticed a few other builders have sort of got into trouble with that because they start at one end and they start working along, and then all of a sudden they get to a cutout and they end up with these odd distances away from it, and then it doesn't line up. On the front section here, where that sort of butts up against the front bulkhead just adjacent to the pedal box, you want a distance from the front back, because obviously if you start measuring from up here where that cutout is for the seatbelt installation, you're not necessarily going to have a very even spacing up here, and you want it to match your floor panels exactly. So, you know, the rivet in the floor panel is directly adjacent to this rivet here, which is going to be 30mm from the end. It'll just look a whole lot neater. I mean, I'm not going to have my floor exposed, I'm going to have carpet on it, and I might even carpet the sides, but it is just something to be aware of in terms of the quality of the finish. Just following on from what I was talking about there, I've actually now started to mark up these panels. I've got both panels side by side, so that way I can make sure that they're as close as possible to each other. So, you know, left to right is going to be symmetrical. If we look here, between this end bit here and the first cutout, we can actually fit 12 rivets with a 19mm spacing at either end, and I've sought to replicate that on the other panel by starting sort of 19mm in and then coming along here and running along. As it transpires, it works out pretty well. If we're looking at the chassis symmetry, we can go from the back here. We're going to fit 21 rivets before we run to this first cutout. Where are we here? And it's 13.5mm between the cutout and 13.5mm here between the end and the first rivet. And it's actually going to be the exact same here on the second panel. 13.5mm here. We've got 20 rivets, well, 21 rivets, so I just numbered them like a bit of a spaz. And then you've got another 13.5mm at the end. So that's how I've worked it out. It should make it all really neat and even both sides, and also give lots of panel strength, because we're going to get virtually the maximum number of rivets in the panel, but also not have any that are too close to the edge of the panel where you could risk tear out or something like that when the panels are flexing. All right, I'm going to be putting a sound system with some speakers in my one. So just for anyone who's doing their own, we're looking at 122.5 down from the top and about 95 from the join here back into the center of a 6.5-inch speaker. And I also 3D printed up just a couple of shrouds so that they'll actually sit on the back of this and protect the speaker. Get the hole there for the cords to come out, and I'll be able to mount that in there and just give them a bit of protection. That's actually just my template one, but I'll print one out of ABS plastic just so that all fits in there and is very neat and won't get all dust and crap into the back of the speaker. We've got the jet heater blaring here today because it's so cold. There's actually snow in the mountains around where I am. But look, I just thought I'd say, I guess, thanks for watching. I seem to be getting a bit of a following to this build, which is more than I expected for certain. One final note on the insulation is just to do with a thing called thermal bridging. And what that means is that despite insulating this panel here, you can run into a really big problem in the sense that you're still going to have a lot of heat transfer through the chassis itself. And that can account for a disproportionate amount of heat transfer through that panel. You can only have, say, 5% of the area, and then 30% of the heat is actually transferred through that thermal bridge. So what I'll be doing a bit later on is actually wrapping some of the key chassis components just in some of that radiation tape, just to avoid as much of that heat getting pushed through there as possible. Anyway, thanks for watching. I hope this is somewhat helpful to other people that are considering building or are building an Ultima. Let me know how you go and whether you've had any good experiences or bad experiences yourself. Cheers.
Okay, thank you. So just make sure when you work with the shit that you get your work boots on and you don't wear gloves.